Okay, so today we're going to kind of dive right in
Yeah.
to something that when you're first kind of learning about CNC machining,
Hmm.
it can be a little bit of a foreign language.
Absolutely.
When you start talking about the different axes on CNC machining centers,
Right.
you hear, 5 axes this and 3+2 that, and then you throw in A and B and C axes, and it's like, wait a minute,
Yeah.
what is going on here?
Yeah. For a lot of people listening, I think, that confusion can actually have real world consequences.
Mm.
If you're trying to, select a machine for a particular project, or if you're maybe looking at the machine you have and wanting to really understand what it's capable of,
Yeah.
being bogged down by the terminology can definitely be a hurdle. And I think that's something that we're going to hopefully break down for you today.
Yeah, for sure.
Yeah.
So in this deep dive, we're going to demystify what all of this means. We're going to explain really what 5-axis machining unlocks, clarify that concept of 3+2 machining, and then really differentiate between, 3 axes and then these more advanced setups
Oh.
so that you can make the right decision for you and what you're trying to accomplish.
Yeah, at its core, I think this whole discussion revolves around a few key ideas, and that's that we have the linear axes, X, Y, and Z, which I think a lot of people are probably familiar with, and then we introduce the rotary axes, which
Yeah.
are usually labeled A and B. And so that the key thing about the 5-axis technology is that it gives you the ability to machine a workpiece from multiple angles in a single operation, which dramatically reduces fixturing time
Yeah.
and minimizes the risk of setup errors. And so you get faster turnaround times, higher precision, which is really critical for intricate components.
Yeah, for sure.
Yeah.
Okay, so let's get into this then. What are these 5 axes on a CNC machining center?
Right.
Let's start with the basics.
Right. So the foundation really is built on the 3 linear axes. And so if you can visualize movement in a 3-dimensional space,
Right.
then the x-axis dictates left to right motion, the y-axis controls forward and backward movement, and then the z-axis handles the up and down motion.
Okay.
And so those 3 axes together allow the cutting tool to reach any point within a rectangular workspace.
Right. Yeah, that's pretty clear. That's easy to visualize.
Yeah.
Now, where do these A and B axes come into play?
Yeah, so these are the 2 additional rotary axes that give the 5-axis machine its added versatility. And so the A-axis represents rotation around the X-axis. So imagine like the entire machine head or the table holding the workpiece, tilting forward or backward.
Okay.
That's essentially the A-axis in action.
Like nodding your head, yes.
Exactly.
Okay.
And then the B-axis is rotation around the Y-axis. So think of the head or table swiveling from side to side.
Okay, so A is nod and B is shake. That's how I'm going to remember it.
Good.
So now how does this combined action of all 5 of these axes fundamentally change what's possible in machining?
So when all 5 axes can operate in a coordinated manner, the cutting tool can approach the workpiece from almost any direction without the need to physically reposition the workpiece within the machine.
Right.
And the single setup capability is really transformative when it comes to manufacturing complex parts.
I would imagine less manual handling also means improved accuracy
Exactly.
or efficiency.
Yeah, and that leads us into this, this kind of interesting middle ground, which is 3+2 machining.
Okay.
Yeah, so you have this 5-axis, which gives you this incredible flexibility, and then there's this term 3+2 machining. So how does that relate to what we've been talking about?
Yeah, I've heard that thrown around quite a bit in the industry. 3+2, what is that?
Yeah, so think of 3+2 machining as utilizing a 5-axis machine, where the 2 rotary axes, typically A and B, are employed to fix the cutting tool or the workpiece at a specific angle. And once this angle is established and locked in, the actual material removal is carried out using only the 3 linear axes, X, Y, and Z. So in essence, during the cutting phase, it behaves much like a 3-axis machine,
Right.
but one that's strategically oriented at this chosen angle.
So almost like you're taking a 3-axis machine and tilting it into a locked position.
Yeah, that's a great analogy. So imagine, a regular 3-axis setup, and you somehow tilted the whole assembly, the spindle and the table, to a fixed angle.
Yeah.
And that's essentially what 3+2 is doing.
Right.
It's using its A and B axes to achieve that tilted orientation and then locking them securely.
Okay, that makes sense.
Yeah.
So what's the advantage then of using a 5-axis machine in this sort of fixed position?
Yeah, there are several key advantages that come into play. One of the significant benefits is that you can actually use shorter, more rigid cutting tools
Okay.
by tilting the tool head. And so, that reduction in tool deflection really impacts tolerance.
Right.
And leads to less vibration during machining and consequently a better surface finish on the part.
Yeah, a shorter, sturdier tool is going to be, less susceptible to that movement
Exactly, like
ease.
those little vibrations.
Another key advantage is that you get enhanced access to various features of the workpiece.
Okay.
So, a purely vertical three-axis spindle might struggle to reach certain geometries, especially on more intricate designs.
Right.
But by tilting the tool or the part, you can gain much easier access.
So expanding the range of features you can machine with that one clamping?
Exactly. And that contributes directly to another major benefit, which is fewer setups.
Okay.
So instead of having to manually refixture a part multiple times to
Hmm.
machine different sides or angled features, you can often accomplish that all in a single setup with 3+2.
Right.
And this not only saves valuable production time,
Sure.
but it also significantly boosts accuracy by minimizing, the potential for errors that can occur with each reclamping.
Yeah, fewer setups and improved accuracy, those are both huge wins
Yeah.
in terms of efficiency and quality. And from a cost perspective, 3+2 machining can be a very economical way to achieve multi-sided machining compared to the full complexity of programming and controlling a simultaneous 5-axis machine.
Right.
And it's particularly advantageous for parts that have multiple flat faces at different angles.
Okay.
The rotary axes simply position you correctly, and then the rest of the machining is straightforward 3-axis cutting.
Mhm.
And I think the critical point to remember here is that during the actual cutting process in 3+2, those rotary A and B axes remain stationary.
Okay.
They don't move.
Right. That's a really important distinction.
Yeah.
So let's draw the line in the sand here. What are the fundamental differences then between three-axis machining, 3+2, and full five-axis simultaneous machining?
Yeah. So the fundamental difference, as we've been touching on, lies in how the machine's axes move, or importantly, don't move during the actual material removal process.
Right.
Yeah.
So let's start with the workhorse three-axis machining. What are its core characteristics?
Yeah, so with 3-axis machining, the cutting tool moves exclusively along the 3 linear axes X, Y, and Z.
Right.
That's its sole range of motion during cutting.
Okay.
And so this is well suited for parts with relatively simple geometries.
Right.
Tasks like drilling holes on a flat surface, creating planar surfaces, or machining, basic 2D profiles or 2.5D shapes where features have a consistent depth.
So, basic plates, straightforward pockets, nothing too deep or with complex angles.
Exactly. However, 3-axis machine encounters limitations with undercuts or machining deep, narrow cavities.
Okay.
And as we discussed earlier, machining different faces of a part often necessitates manual refixturing
Right.
for each new face, which increases both the cycle time and the potential for alignment errors.
And every time you manually adjust a part, that's an opportunity for slight inaccuracies.
Exactly.
Yeah. Okay. So how does 3+2 then compare?
Yeah, so 3+2 machining, as we've established, utilizes the rotary axis to orient and then lock either the workpiece or the tool head at a specific angle. And once it's secured, the cutting operation itself is performed solely using the X, Y, and Z linear axes.
Okay.
And this makes it remarkably efficient for machining multiple faces or features that are oriented at fixed angles relative to each other, all within a single clamping.
So more intricate than pure three axis, but
Right.
without the repeated manual position.
Exactly. And it excels with parts that have several flat surfaces meeting at compound angles.
Okay.
You gain the benefits of reduced setup times and improved accuracy compared to, handling the same part
Yeah.
across multiple 3-axis setups. And so it really occupies that valuable middle ground,
Right.
offering a practical and cost-effective solution for more complex parts without the full investment and programming demands of simultaneous 5-axis.
Okay. And then that leads us to the big dog five-axis simultaneous machining. What's the differentiator there?
Yeah, so the defining characteristic of true 5-axis simultaneous machining is that all 5 axes, the 3 linear X, Y, Z, and the 2 rotary A and B, can move in a perfectly coordinated manner at the same time during the cutting process.
Got it.
And this allows the cutting tool to maintain optimal engagement with highly complex 3-dimensional surfaces.
Wow.
You think about the complex curves on an aircraft wing.
Right.
Those are often machined using simultaneous 5-axis to achieve the required aerodynamic performance
Right.
and the tight tolerances.
So it's not just getting to the angle, it's about being able to adjust that angle while you're cutting.
Exactly. And this capability is absolutely essential for machining true 3D surfaces and intricate contours.
Okay.
Consider shapes like turbine blades, impellers, sophisticated medical implants, or highly detailed molds.
Right.
These often feature flowing surfaces and undercuts that simply cannot be efficiently or effectively produced
Right.
with just 3-axis or even 3+2 machining.
So that's the choice for the most demanding parts.
Absolutely. Five-axis simultaneous machining offers the highest degree of flexibility and often enables complete machining of incredibly complex parts in a single setup,
Right.
which is paramount in industries like aerospace and medical, where precision and minimizing potential error sources is critical.
Yeah. Okay, this is really helpful to visualize the differences.
Yeah.
Would you be able to kind of summarize these key differences across some specific criteria?
Absolutely. So let's consider it across, several key aspects. So if we look at the axes utilized,
Okay.
during the cutting operation, three-axis employs just X, Y, and Z.
Okay.
3+2 uses X, Y, and Z for cutting with A and B fixed for positioning.
Right.
And five-axis simultaneous uses all five, X, Y, Z, A, and B, all moving in concert.
Okay, what about the movement during the cut?
So for three-axis, it's purely linear motion.
Okay.
For 3+2, you first position the A and B axis, and then the cutting is linear, using X, Y, and Z.
Okay.
And for five-axis simultaneous, you have concurrent, linear, and rotary motion.
Okay, and how does this impact the complexity of the parts you can machine?
So three-axis is best suited for simple, primarily flat geometries.
Okay.
3+2 can handle multi-sided parts and angled flat features.
Right.
And five-axis is indispensable for machining complex curves and undercuts.
What about the number of setups required for a given part?
So three-axis often necessitates multiple setups when machining different sides.
Okay.
3+2 generally requires fewer setups for multi-sided parts.
Okay.
And five-axis simultaneous often makes single setup machining achievable even for very complex components.
Wow, so that's a big time advantage.
Right.
Now, considering, the individuals operating these machines, what's the difference in programming complexity?
So three-axis programming is the most straightforward.
Okay.
3+2 introduces moderate complexity due to the need to program the initial rotary positioning.
Okay.
And five-axis simultaneous programming is the most complex,
Right.
often requiring sophisticated CAM software to generate those synchronized movements.
So naturally, the operator skill required would follow a similar trend.
Precisely.
Okay.
Operating a three-axis machine requires a foundational skill set.
Right.
3+2 demands a moderate level of expertise to manage those positioning aspects.
Right.
And five-axis simultaneous operation calls for advanced knowledge and considerable experience.
And I would imagine that the cost of these machines also reflects their increasing capabilities and complexity.
Generally, three-axis machines represent the lowest initial investment. 3+2 machines fall into the mid-range, and five-axis simultaneous machining centers command the highest price.
Okay, finally, what are some typical applications where each of these technologies shines?
So three-axis is well-suited for simple, high-volume production runs.
Okay.
3+2 is ideal for parts with multiple angled faces.
Right.
And five-axis simultaneous is crucial for industries like aerospace, medical device manufacturing, and mold making, where complex geometries are the norm.
Okay, that really lays it out. Well, those different categories help. So
Yeah.
you mentioned earlier that 3+2 isn't just, kind of a limited version of five-axis. It's
Right.
a very distinct approach, and it's valuable in its own right. Could you elaborate on that?
Yeah, what's particularly interesting about 3+2 is that it represents a very intelligent and often cost-effective strategy
Yeah.
to really significantly expand the capabilities of a three-axis machine without making the full leap.
Right. Simultaneous five-axis.
Right.
It provides the ability to tackle multi-sided machining with fewer setups, leading to tangible improvements in accuracy and efficiency for a specific spectrum of part geometries.
Okay.
So it effectively bridges the gap between the simplicity of three-axis
Right.
and the complexity of full five-axis motion.
Okay. So now that we understand the differences, how do you decide which one is right for you?
Yeah, that's the central point. The optimal choice, isn't about selecting the most advanced technology. It's
Correct.
about identifying the one that best aligns with the specific types of parts you're manufacturing, the level of accuracy you require, your anticipated production volume, and naturally your available budget.
Right.
So it truly comes down to tailoring the machining technology to your unique operational requirements and business objectives.
So what are some of the key factors that our listeners should be considering when they're making this decision?
So the very first thing to thoroughly analyze is the part complexity and geometry that characterizes the majority of your work.
So if your primary focus is on simple prismatic parts, machined predominantly from one or two sides, then a three-axis machine will likely be the most efficient and economical solution.
Okay.
If you frequently encounter parts with features on multiple faces or compound angles, but those features are primarily planar, then 3+2 machining can offer a substantial advantage.
Okay.
However, if your core business involves intricate curves, undercuts, and flowing surfaces, such as those found in molds, impellers, or aerospace components, then simultaneous five-axis capability will likely be essential.
Right. So you've got to think about the job you're trying to accomplish and the capabilities of the machine. What about production volume and cost?
Yeah, so for high-volume production of those simpler parts, three-axis machines generally provide the lowest cost per part
Right.
and are simpler to operate and maintain for lower-volume, highly complex parts. The time savings from reduced setups and the ability to complete machining in a single clamping on a five-axis or even a 3+2 machine can actually lead to greater overall efficiency despite the higher initial investment in the machine.
Right.
So 3+2 often strikes a good balance for medium complexity and production volumes.
And of course, you can't overlook budget and operator skill.
Absolutely. The initial capital investment in the machine itself escalates as you progress from 3-axis to 3+2 to simultaneous 5-axis. But the cost implications don't end there. The complexity of programming and operating these machines also increases.
Sure.
Simultaneous 5-axis machining in particular necessitates advanced CAM software and highly skilled programmers and machinists.
Right.
So you need to factor in not only the machine acquisition cost,
Right.
but also the expenses associated with software and the required training for your team.
What about accuracy required for the finished parts?
So for multi-sided parts, both 3+2 and 5-axis machining generally offer superior accuracy compared to performing multiple setups on a 3-axis machine, simply because you're minimizing the potential for accumulated errors
Right.
with each refixturing.
Makes sense.
For achieving the absolute highest levels of accuracy on highly complex contours, simultaneous 5-axis is typically the preferred choice.
Are there any other kind of practical factors that people should keep in mind?
Yeah, floor space and maintenance can also be relevant considerations. More sophisticated machines like 5-axis centers can sometimes have a larger physical footprint
Right.
and may involve more intricate systems,
Right.
potentially leading to higher maintenance requirements compared to simpler 3-axis machines.
Yeah.
So you'll
Right.
need to assess your available shop space
Right.
and your maintenance capabilities.
Okay, so it seems like the message here is you really need to understand the type of work you're doing,
Right.
both now and in the future, and align the machine technology with those demands, but keeping in mind budget and skill level of your team.
Exactly. It's vital to analyze the majority of your current and anticipated workload. You don't want to overcapitalize on a 5-axis machine if 95% of your projects are perfectly suited for a 3-axis.
Right.
Conversely, if your target market is evolving towards more complex geometries,
Right.
then investing in 3+2 or 5-axis capability could be a crucial strategic move for future growth and competitiveness.
This has been a really great deep dive into the world of CNC axes.
Yeah.
So as we wrap up, what's the key message you hope our listeners take away?
I think the fundamental takeaway is that selecting the right CNC machining technology, whether it's 3-axis, 3+2, or 5-axis, ultimately depends on a clear understanding of their core movement capabilities and how effectively those capabilities match your specific part. Complexity production demands budget constraints and the expertise of your workforce.
And for our final thought today,
Yeah.
we encourage you to consider that, look beyond just your immediate projects.
Right.
What potential future opportunities could different machining technologies unlock for your business? Exploring those possibilities might just lead you down some exciting and profitable new avenues in advanced manufacturing.
Absolutely.
Thanks for joining us for this deep dive.